Okay, lesson point 3 is solving equations with variables on both sides. So there are lots of different examples to give in this lesson, but I want to make sure we get to the more real-life application ones at the end. So we're just going to look at a couple that you aren't really familiar with or haven't seen before this lesson in terms of just the written equations with numbers, and then we'll get into some real-life word problem written equations. So a couple that you probably haven't seen prior to this lesson are equations that result in no solutions, where there is no solution to be found, or infinite solutions. So this example of 2x plus 1 equals 2x minus 1 is going to result in one that has no solution, and we'll see why after we go ahead and simplify it down as much as we can. So I'm going to begin by getting rid of the x's from this side, okay, which means I have to get rid of them over here. And right away you can see that you have a problem because you're left with no x's, right? And that's kind of the whole point of this unit, is to solve for the variable. Because we are left with a positive 1 equals negative 1, this solution can never be true. So when you have narrowed or simplified the equation down as far as you can, and you are left with an answer that can never be true, you are left with an answer that is said to have no solution. Okay, and this is in a direct contrast to an example such as this, 1/2 times 6t minus 4 equals 3t minus 2. So we've got a distributive property problem here that we need to work through. When we distribute this 1/2, you're going to end up simplifying it to 3t minus 2 equals 3t minus 2. Take these away, and we are left with negative 2 is equivalent to negative 2. This is an example of a statement that will always be true. 1 equals 1, 10 equals 10, negative 100 equals negative 100. When you're left with a statement that will always be true, this is going to result in an infinite number of solutions. So those are the two types of equations that we haven't seen prior to today, but still require you to think about distributive property, combining like terms. So these are the two new ones you'll want to keep in mind. So the other, as we move into the real world, we are going to be thinking about two circles that are the same size. And this first circle has a radius, so you're going to have to pull out your vocabulary for circles here, has a radius of x plus 2. And this circle, remember they are identical in size, has a diameter of 3x. Well, if you remember or know what you know about circles, you know that if something has a diameter of 3x, in this case, the radius of that circle is really going to be 1.5 times x, because radius is half of diameter. So if we want to write an equation that shows that these two radiuses are the same, you are going to say that this radius of x plus 2 is equivalent to the radius down here of 1.5x. This is a true statement. Both of these radiuses are the same. So now we are going to start taking these x's away, and we are left with 2 equals 0.5x, okay, because we took that x away, and so now we have 0.5x. So now we can recognize, okay, well, I've got some whole numbers. I need to get this x by itself. So I divide by 0.5, divide by 0.5, and I am left with 4, is 2 divided by 0.5 is 4, equals x. Now that's not my final answer. That is the answer to what x is equivalent to. So now when I plug this back in to x, I can end up with what the radius is, right? So if I have x plus 2, and this x is now 4, I can see that the radius is 6. I double check it with here. 1.5 times my x, which is a value of 4, I am going to end up with 6. So my radius equals 6. Now in this particular problem, they want us to solve for the area, okay, of the circle. And so this one is going to look like pi, like how would we solve it? Pi times radius squared is your formula to solve for the area of a circle. So you would plug in pi, your radius is 6, and you're going to square that. You do that first according to PEMDAS using your exponents. So you would end up with pi and 36, and then of course they would refer to it as 36 pi. So the area of this circle, in regard to just getting a formula to solve for it, would be 36 pi. And then of course you would plug in your 3.14 from that. But we just need to get the formula for this one. All right, we are going to look at 2 more real-life application problems. So this one, a boat travels a certain number of miles per hour from one island to another island in 2.5 hours. The boat travels 5 miles per hour faster on the return trip of 2 hours. So what is the distance between the 2 islands? So you can picture your 2 islands, and we'll just have them going from here to here. This trip, they go a certain number of miles per hour. The whole trip takes 2.5 hours. The return trip, they're going 5 miles per hour faster than they went on the original trip, and they made it in 2 hours. So we know they're going 5 miles an hour faster on this return trip. It took them 2 hours. The original trip took them 2.5. And I know that the distances are equivalent. And keeping in mind what is the distance between the islands, that's the final answer that we're going for. So the 2.5 hour trip, they traveled a certain number, an unknown number of miles per hour. That unknown number we're going to represent with x. We know that this trip, distance-wise, is equivalent to the return trip. And that return trip took them 2 hours because they were traveling a certain number of miles per hour, and we know they were also going 5 miles an hour over what they did on that initial trip. So this is the miles per hour of the initial trip, plus the additional 5 miles per hour on that return trip, which is the whole reason why they were able to get there faster. So miles per hour for the original trip, same number goes here because that's that same number of miles per hour plus 5. So I'm going to recognize a couple things here. The 2.5 stays the same, but I have distributive property that I need to do here to simplify. So 2x plus 10. So now I'm going to, I don't want to end up with a negative x, so I'm going to take the 2x away from here. And I will end up with 0.5x equals 10. I want to get x by itself. And the x is going to equal 20, because taking a whole number, dividing it in half, is going to give you a larger number. So x equals 20. Now do keep in mind, this x is the miles per hour. It is not your answer to the question. The answer to the question is, what is the distance between the islands? So now to answer the question, you have to plug in that x back up into one of these two. So 2.5 times 20 is going to give you 50 miles. 2.5 times 10 would give me 25. I double that, and that gives me 50 miles. All right, and the last one. One movie club charges a $100 membership fee and $10 for each movie that you rent. The unknown here is you don't know how many movies you've rented. Another club charges no membership fee, but movies cost $15 each. Again, you don't know how many movies you've rented. Write and solve an equation to find the number of movies you need to buy for the cost of each movie club to be the same. Okay. So let's just write what we know. We know that one movie club charges a $100 membership fee and additionally $10 for every movie you rent. You just don't happen to know the number of movies here. That's your variable. The second movie club has no membership fee, but they charge more money per movie that you rent. What we need to figure out is at what point are the two costs equivalent. So we're going to start by combining like terms. Take your 10 away here. And you end up with 100 is equivalent to 5x. Get your x alone by dividing by 5. And you are going to find that your answer is 20. So if you go back and you think about what this x means, it represents the number of movies you would have to rent to make the situation equitable, where it wouldn't matter if you were choosing membership for movie club number 1 or movie club number 2. As long as you rented 20 movies, they would both be equal.